Alright, hey class. I know first thing you probably notice is I'm not outside right now. Alright, that's because it's pretty dark out. I think it's going to rain if it's not raining already. Alright, so I'm inside my apartment. Don't go too crazy. Alright, this is all you're going to see. First, the goal for you today is for you to be able to model subtracting integers. Alright, so just like the video you watched that dealt with modeling adding integers, we're going to use green dots to represent positive values and red dots to represent negative values. Now, if you don't have colors at home, alright, no color pencils or markers or crayons or whatever, and you're just using a pen or a pencil, use a solid black dot to represent a positive value and use an open white dot to represent a negative value. Alright, so first, 6 minus 2. I'm sure all of you know how to do that. Our answer is going to be 4, of course. Alright, but these 6 green dots I'm going to use to represent positive 6. Now, you're going to notice that I use 2 red dots to represent that 2. Now, I know some of you are probably thinking, Mr. Schilling, all you're doing is taking positive 6 minus positive 2. And you're right, that is what we're doing. But I want you to think about these numbers in terms of the sign that is directly to the left of it. Alright, to the left of the 6 is nothing, so if there's nothing to the left of a value, it's always positive. The sign to the left of that 2 is a minus sign. Alright, but if you don't know this already, minus signs and negative signs are almost interchangeable. They mean the same thing. Alright, even though they're different, right? Minus means you're subtracting something away. A negative value means you're taking that value away. So essentially they mean the same thing. So when we add and subtract positive and negative values, I want you to think about these numbers in terms of the sign that is directly to the left of it. In this case, I want you to think about that minus as a negative sign, which is why I use 2 red dots to represent that 2, alright, or that minus 2, that negative 2, even though technically it's a positive value. So, what I'm going to do is just like before when we added integers, I have to take away a red dot for every green dot. Alright, for every positive value, I have to take away a negative value. So, I'm going to cross out this negative, this positive, this negative, and this positive. And all I'm left with, if we move all of these dots over to this side, are going to be 6 positive dots, 2 negative dots. So I'm going to cross those out like I did before. And all I'm left with is 4 positive dots, which means my answer must be positive 4. Alright, next. Negative 8 minus 5. Again, I'm already telling you that that's a negative value, so I used 8 negative units. Alright, 8 of those red dots to represent negative 8. And even though this 5 is technically positive, I want you to think about this value in terms of the sign right to the left of it. Sorry, I shouldn't say right to the left of it. I should say directly to the left of it. Anyway, we've got 8 red dots, 5 red dots. When we combine them and we move them all over to one side, we have 13 red dots, which means our answer is negative 13. Alright, remember, if you cannot cross anything out because you can't cancel a positive and negative, you just combine them, move them over, and that's where our answer is going to be, negative 13. Next one, last one on this slide. I've got negative 3 minus 4. So, I use 3 red dots to represent negative 3, and 4 red dots to represent that minus, or that negative 4. So, since I have nothing I can cross out, that must mean I have to combine the dots. I have to combine the values. So, I'm going to move them all over here. I have nothing to cancel out, so that means we have to count them all up, and we're going to get negative 7, because we have 7 negative units or negative values. Alright, so that's it for this slide. Alright, moving on. Didn't go as far as I wanted that to. Okay. So, again, green dots are positive, red dots are going to be negative. Real quick, get this down. When a minus sign and negative sign are next to each other, together, they become an addition sign. Alright, this is real important. Alright, very important term, or sorry, not term, fact to remember about adding and subtracting integers. But for today, subtracting integers. Alright, check it out. I've got positive 10, which I represented using 10 positive dots or green dots. But you're going to notice that I haven't made 7 red dots for that negative 7. And this is why. This rule right here. Alright, whenever you have a minus sign and a negative sign right next to each other, you combine them into an addition sign. Alright, so I'm going to erase these. Now I'm going to turn that into plus 10 plus 7 equals 17. That's why I use 7 green dots. Because really, after I take this rule into consideration, I'm going to get positive 7 instead of minus negative 7. Since I have nothing I can cross out, all the dots moved over, and I was left with positive 17. Alright, the next one. Ooh, alright. A lot of negative signs in there. Well, and technically a minus sign. We got negative 6. So I represented negative 6 using 6 red dots. Now I know, again, you're probably wondering why I didn't use 9 red dots to represent negative 9. And it's because of this rule. Alright? This rule is extremely important, so you better get this down. These two negatives are going to combine into a positive. So now I'm left with negative 6 plus 9. And that's going to give me 3. Because if you remember back to when we modeled adding integers, all you got to do is for every negative value, cross out a positive value. And we're only left with 3 positive values at the end. 3 green dots. Which is why my answer is positive 3. Alright, and this next one. I've got negative 12, so of course I use 12 red dots to represent it. Minus negative 4, and again, using this rule, I'm going to get rid of these two negatives, or sorry, the minus sign and the negative sign, and I'm going to turn that into an addition sign. Which means this 4 is now considered positive because of the sign right to the left of it, that plus sign. So now what I'm going to do is cancel out a negative for every positive value until I'm only left with one type of dot. So there goes a positive, there goes a negative. Gone positive, gone negative. Take away the positive, take away the negative, take away the positive, take away the negative. All I'm going to be left with are 1, 2, 3, 4, 5, 6, 7, 8 negative dots, or negative values, which is why my answer here is negative 8. Alright, let's get this out of the way. Again, green dots are positive, red dots are negative. This is a rule that you do not always have to use if you don't want to, but if you feel comfortable using it, you can. When you only have a minus sign between two integers, you can change the minus sign into an addition sign, but you must also make the second value negative. Alright, so this is what I mean here. We've got negative 7, 7 red dots, minus 4, 4 red dots. Because remember, technically we're thinking about this 4 in terms of the sign to the left of it, which is that minus sign, or what we can consider a negative sign. Alright, so, like the rule says, I can change this minus sign to addition, but if I do that, I have to change the second value into a negative integer. So now, check it out. Negative 7 plus negative 4. And now I just turn this problem into an addition problem. Alright? And you already know how to model an addition problem. Negative 7, 7 red dots, negative 4, 4 red dots. We've got no positives and negatives that can cancel each other out, so they're all going to move over. And we're left with negative 11 for our answer. And the last slide. Don't worry, I know this video's taking a little while. Okay? But what I want you to do is I want you to try and work these problems out using the method I just went over. So, pause the video, go ahead, work them on your own, and then let's see if you got them right. Alright, I'm hoping you pause it, otherwise I was only gone for like 2 seconds, okay? But, let's work these out. So, I've got a positive 2, because remember, if there's no sign to the left of it, that means it must be positive. Well, it's taking me a little while to draw that. So, positive 2 means I'm going to use 2 positive dots. And this 10, which technically it's positive, but I want you to think about it in terms of the sign to the left of it, which is a minus sign or a negative sign. So, I'm going to make this 10 units. And remember, this is negative. And so what we're going to do is for every positive value, cancel out a negative. Oh, and if you want to use that last rule I just went over, you could change this into a plus sign, and then of course change this number into a negative. Alright, which doesn't change our dots at all. So, for every positive, I cross out a negative. And all I'm left with is negative 8. And I'm not going to draw the dots on this side. Alright, you guys can see that those are just going to move over. So, next, negative 9 minus 4. Well, I've got negative 9, so I'm going to draw 9 red dots. And I've got a minus 4, which, remember, we're going to consider as a negative. So, 1, 2, 3, 4. If you want to, you can use the rule I just went over. You could change this minus into a plus, and then change the second value into a negative. Doesn't change the dots. We still have negative 9. We still have negative 4. Since we have nothing to cancel out, all these red dots are going to move over, and we're going to end up getting negative 13 for our answer. Alright, and the last one. You better have got this one. Alright, look. We got negative 5 minus negative 13. Alright, so I'm going to draw 5 red dots for negative 5. But I'm not going to do anything yet to that negative 13 because there's a minus right in front of it. So, what are we going to do? Change that into a plus. Think about this real quick, class. Now, usually, if I have something written like this problem, negative 5 minus negative 13, these are offset, alright, not lined up exactly, but an easy way to remember what to do is when you have a minus and a negative right next to each other, let's say they are lined up like this, all you're going to have to do is connect them and then draw a line through it. I know that helped me remember, alright, that rule. So if you want to use that to help you remember, use it. If not, just try to remember that when you've got a minus and a negative right next to each other, they're going to combine into a positive. So, I'm going to get rid of that. And now this 13 is a positive value. So, I'm going to draw 13 positive dots. 5, 6, 7, 8, 9, 10, 11, 12, 13. Alright. Now, what I'm going to do is cancel out a negative for every positive. So, boom, boom. Making noises just like Emerald. If you even know who that is. The cook, maybe. Alright, anyway. So, all the negatives are gone, and all we're left with are 1, 2, 3, 4, 5, 6, 7, 8 green dots, which are positive. So my answer is going to be positive 8. Alright, I know this is tricky, but if you're taking good notes, you're paying attention, you're not just copying this stuff down, but you're also listening to what I'm saying. Alright, this should be a piece of cake. But if you need help tomorrow, I'll be more than happy to help you. Alright, have a great night, guys. See ya.